type in your chat box, or if you guys are watching this on YouTube, please do type in your mail ID so that our team can get back to you. And which we are a couple of minutes in, so I'm just gonna wait for a minute or two, and then we'll straight away get started. Again, for the people who are just joining in, I would probably repeat this thing again. Uh, we, at the end of the webinar, are going to share a couple of resources about architecture of intelligence, or let's say the role of AI and machine learning in architecture. We will be dropping in some really good references of the books, some PDFs. We will be sharing a script or two with you guys in order to explore and work on it. So guys who are streaming through Google Meet, or if you are watching this on YouTube, please jot down your names, type down your names, your mail ID, so that someone from our team can reach to you guys, and then we would love to share all these resources with you all. And with this, we'll get started. So, very good afternoon, everyone. I hope everyone is doing okay and are well at their respective ends. My name is Piyush Prajapati. I'm an architect and computational designer currently practicing in Dubai. I'm really looking forward to today's webinar, and I would like to thank the team of Equim for organizing this opportunity to have conversation with you all. I feel it is a very great initiative to keep us all connected virtually, especially during this time of pandemic. And I genuinely hope this webinar would help in bringing some fresh and new perspectives towards design and architecture. So today's topic of discussion and webinar is architecture of intelligence, identifying the importance and the role of AI and machine learning in architecture. So before we dig in deep into artificial intelligence, I would like to highlight on the timeline of AI architecture with respect to design invention, design theories, and architectural innovations. In the year 1930, the era of modularity came into picture, where we saw few amazing concepts in design. The very first argument on smart architecture was stated by Walter Gropius, where he spoke about using computers in architectural design. And soon after that, we came across modular system of anthropometry by Le Corbusier in the year 1945. And an interesting inference is that by unifying both the ideas and concepts, Moses Chavde designed Habitat 67 in Montreal, Canada. The housing complex is one of the most admired buildings of the modularity phase, and it is still praised by many. But the Dartmouth Summer Research Project on Artificial Intelligence, which was a 1956 summer workshop, is widely considered as a founding event of artificial intelligence as a field. The project lasted approximately 6 to 8 weeks and was essentially a brainstorming session. 1960 onwards, the era of computational design emerged, where we saw invention of sophisticated computer programs such as AutoCAD and CATIA by Frank Gehry, which is also known as Gehry Technologies. Christopher Alexander spoke about pattern language in architecture, and MIT came up with the first ever chat box in the year 1966. Well, to be honest, I really don't want to bore you guys with the dates and the list of theories, but here is the interesting catch. The era of parametricism came early 1990s, where we witnessed some of the amazing projects like Vitra Fire Station by late Zaha Hadid. I'm sure many of you are aware of it. And the invention of Grasshopper as a designing tool in the year 2007. But now, we have already passed the era of parametrics and we are currently in the period of artificial intelligence. Well, we did have a couple of major developments, but not much has been explored in this phase. And one of the major breakthroughs in the architecture of intelligence is the application of neural networks in designing. So if I have to define neural networks, it is a series of algorithms that aims to draw relationship from complex data sets to process by mimicking the functioning of human brain. Thus, it is also called as an artificial brain. And the generative design philosophies of neural network came in the year 2014. Well, to be honest, neural network is quite complex and a strong subject in itself. Detailing it out would be a matter of a separate webinar. So for now, let's get into a state of mind that neural network is basically the part or subset of artificial intelligence. To simplify it, neural network is a pattern recognition algorithm which you usually use to unlock your smartphones basically by using a face ID or object detection. So let's not deviate from the main theme, and I would like to pull in the first slide again and break down the topic in a couple of important keywords. And let's get straight to the point where we can address the elephant in the room, that is AI, machine learning, and architecture. Well, architects are not sure what to think about artificial intelligence. You're probably very familiar with how AI will change industries like cybersecurity, medicine, and manufacturing. But well, what about architecture? This brings us to three important questions, that is what, why, and where of artificial intelligence in architecture. So AI is basically intelligence displayed by machines and software. Today, AI is all around us. If you own a smartphone, tablet, PC, or even a car, it is likely that it runs on some form of an AI, be it Siri, Cortana, or even Google Maps. The ever-growing connection of people via technology is enabling a more open and transparent outlook into every person's life. Now let's understand why is this important. Why is intelligence is so important in architecture? So by knowing what we like, what we post online, what we buy and where we go, our smartphone, tablets and computers through complex algorithms, they know us empathically better than we do know ourselves. The data is constantly being uploaded onto a cloud, and the information gained can be analyzed by an AI to automatically generate plans. And the plan can then be improvised later upon architects and by designers, and the result of which would be a completely finished design. Now that's the power of an AI. To give you an easier example, let's look at the Tesla cars. They all have AI pilots in the car, and with every journey, car uploads the data to the cloud server. The data is mainly about the road congestion, road openings, and commute time, something which is very similar to Google Map. So the next car that comes onto the street has now updated information on what routes to choose. And the way we designers and architects can benefit from it is by analyzing this very data set. You might come up with a very simple solution of a roadblock, or let's say a heavy traffic, where just by increasing the road width by 1 meter could solve an urban problem, rather than by building or proposing a whole new flyover. Again, guys, just gonna take a small pause, and I would request everyone. Probably some of you guys have just joined later or somewhere in the middle of the presentation. So do drop down your names and your mail ID in the Google chat. And if you are watching on YouTube, people on the YouTube, they can comment your name and you can comment down your mail IDs as well. At the end of the webinar, we will be sharing some resources with you all, and someone from our team will definitely reach you guys. Again, talking about where this entire idea of artificial intelligence it can be applied, their application is quite vast as well. By already knowing everything about us our hobbies, likes, dislikes, activities, our friends, our yearly income, AI software can actually calculate population growth. It can prioritize projects, it can categorize streets according to its usage, and so on. And thus, by predicting a virtual future and automatically draft urban plans that best represents and suits everyone, basically shaping the future design environments. Well, it all looks fancy, but how do we do it right? How do we get into a right mindset of using such principles and ideas in the architecture and design? What are the ways we can truly understand computer cognition? And by cognition, I actually mean intelligence. These are the few questions you might think upon. And as I said initially as well, the aim of this webinar is to let you guys explore the unexplored potential of this field, that is artificial intelligence in architecture. Having said that, let's jump on to the interesting part, which is the process. Let's assume we have to design, like we have an architectural or a design problem. In the initial step, we would include the learning and theories and building up the understanding of the design problem. Let's say we have to design a housing complex. You would then start by analyzing and researching about different types of housings, the definition of housing, and then you would gather up a collaborative understanding of it. In the next step, we would draw inferences from the site at micro and macro level, that is, at the city and at the site level. Here, we would bring up the understanding of road network, connectivity to the housing complex, potential entry-exit points, and its impact on the society. Upon gathering all the necessary information about design problems, the next crucial step is to create an algorithm that can understand all the parameters you would state. In simple terms, we would state the list of arguments which would then derive the design, and let's call them the design parameters. Now here is the interesting bit. Based on your list of design parameters, there are infinite number of design possibilities on how we can orient the building, where we should propose doors and window openings, or what should be the ideal internal and external circulation. And doing it all by human mind, it will probably take up months in determining the right design option. What computer intelligence would do is it would take all the listed design parameters, it will understand them, it will process them, and it would compute to give you one from the million design possibilities. Now, instead of brainstorming over million designs, which usually takes up a huge amount of time, we would now have computationally driven design solutions. Let's assume some 5 to 6 options, which would satisfy all the listed parameters. And as a designer, your role is to choose the right one tailored to your aesthetics. This process is called form finding, where you're determining the form of the building by computationally driven tools. Now, you may think if the computer is doing the job, what is the role of designers, right? If you have to record the number of possibilities of the different design iteration, here is a screen recording of a very basic AI model, where the form is broken down to various modules to find the best design solutions for the housing complex. My question is, how much time would you take to derive the right answer? In this case, it took just 56 minutes. So to summarize, AI would not take up our jobs. Rather, it would act as a catalyst in finding the right solutions for the design. Well, honestly, computer is a dumb machine. So what it is good at is its computing skills, which we humans, we obviously lack. It is important as designers and as architects to identify the right balance between the two. And AI would just give us a form. And it is the role in hands of designers to sculpt the emotion out of it at max. It can give you some 5 to 6 design possibilities, but again, it is in hands of an architect to shape the final vision. To give you an easier example, the form here can be tailored to numerous design languages, be it the housing complex done by Moses Shavde or the community housing by Briak Angels. The final product would always reflect and is actually backed up by a strong research done by computer intelligence or an AI. Here is another example of computationally driven floor plan, where the aim is to increase the productivity of the office layout. It is done by enhancing the spatial and visual connectivity, by manipulating the internal wall partitions, the furniture layout. The AI calculates the desired number of the meeting rooms, the area required per seat, and even the total capacity of the floor. Having said that, let's look at another form finding example. The mixed use project aims in developing the form via computational measures. The final form would look something like this, and I will highlight the reasoning behind it. Keeping a note of the access route, the site also has direct connection to the water feature. In the very first process of optimization, the goal of the AI algorithm is to identify the right location of the building form so that the towers have the maximum views. In the second stage of optimization, the AI calculates the right orientation of the building to improve the visual connectivity. Thirdly, the form is then studied for the sun movement and the solar radiation using generative learnings. The parameter over here is to reduce the solar gain and increase the daylight factor. The factor of mutual shading is also considered here. Lastly, the build form are then analyzed and tested for the wind intake. The atriums and the openings are strategically placed and oriented to make most of the wind movement. The same exercise is done for all the towers here. And upon optimizing all the above parameters, the final build form would look something like this, which is the computationally driven form and thus is the right amalgamation of human and computer intelligence. Having said that, I would like to give you a small example of a real-time design solution which has been executed on the site. And the project I'm going to show you now is Al Seif in Dubai. It is a mixed-use stretch of about 1.8 kilometers, having residences, retail, and commercial spaces. And the design is inspired from the traditional souk buildings of this region, having wind towers and niche courtyard spaces. Since the site is located next to the waterfront, one of the main criteria while designing the stretch was to enhance the public movement and visual connectivity to appreciate the spaces and the waterfront promenade. Upon having the general master plan, it was important for us to monitor the building height so as to build the character without being hindrance to the views. We then created the machine learning algorithm to find the right balance of the both to achieve the best building skyline. Here is a video highlighting the numerous design possibilities. And after generating the right massing model, I would like to show you the final result. Here are some professional shots of the building, the promenade, and the quality of the built form. The traditional architectural style where each house is or the building has a story of its own. Some buildings are designed to look as if they were built in 1960s, whereas with some darker walls and less lighting, where while some have the lighter walls with much more intricate details. So again, an AI would just give you a massing or let's say a broader understanding or let's a logic out of it, whereas as a designer, as an architect, it is in our hand to cultivate, to sculpt the emotion, the aesthetics out of it. So guys, again, if some of you are dropping out, some of you are dropping in as well, so I would request everyone to drop down your names, type down your names and your mail ID in the chat box. If you are watching on YouTube, you can comment it over there as well. And someone from our team will definitely reach back. We would like to share some of our resources, some of these presentation slides, some of the PDFs, interesting readings, and the book references. I would love to share these with you guys. So if we have your mail address, it'll be easier for our team to reach to you, and we can definitely share the data or the resources with you by the end of by the end of the day. Yeah. Moving forward, I would briefly talk about my research project on urban design, and the name of the project is Neural Network Public Places. The research aims at redefining the experience and the design of the public spaces in the age of artificial intelligence. Well, the soul of research project is based on big data, and big data is considered as one of the biggest byproducts of 21st century. Almost everything we do produces data, from swiping credit cards to emailing, liking photos on Facebook, on Instagram, and requesting directions from the Google Map. Big data today is acting as bread and butter of AI algorithms and computational thinking. The term is even dominating the field because it reveals human patterns. When data sets are read and analyzed in bulk, it reveals inner human sociology. For example, the data set gathered from Google Maps would reveal how we humans interact with spaces, connectivity, and the routes we choose. These data would help in designing better urban spaces. GPS system and the location-based services give access to important amount of data that is currently being used mostly for the traffic analysis, but which, if properly processed, could open up to infinite possibilities for the planning. The research project even took a broader perspective of the city to analyze at macro level upon overlaying important urban fabrics such as building height, residential and commercial layers, the green spaces, the density map basically of the city and the city buildings, and most importantly, the choice map. Well, the choice map reveals the deeper finding of the city. Choice map again is an AI algorithm to calculate the probability of you selecting a particular or a specific route. For example, it is known that all the roads are interconnected to each other. Some acts as primary road, whereas some are secondary and tertiary road networks. Given a chance that you can go anywhere like in any direction, the choice map would highlight the important road connection, where no matter which direction you take, you would end up taking those important road networks. And after establishing the importance of road networks, the next best thing is to measure the quality of an urban environment. The quality of any environment can easily be judged by mapping what you see and what you avoid seeing it. We can map how much area can be seen from a particular point or a very specific point. And again, it will infer a lot about spaces and characteristics of public spaces, promenades, gullies, or even sikas. And mapping it on a city level, the research explores the visual preferences to measure and judge the quality of spaces. On your right, you may see a graph representing the visual areas for the selected routes. So the guys, during the presentation, if you have any questions, feel free to type down on the chat box as well. I would love to answer all of them at the end of this presentation. And again, please make sure that you have your mail address commented so that someone from our team can reach you guys, and we would love to share some of the resources by the end of this webinar. So now that we have already determined the importance of road network, the next important step is to map human movement. Let's say you have to go from point A to point B. There are 100 ways you may choose your route, and all of them would probably inculcate different characteristics. So which one is the best? The research aims to build the comparison between the human navigation and the navigation chosen by an AI model. It is inferred that there are a lot of unforeseen factors which determine human movements. And you might find a chart while on your way, and you might take a detour to reach to your destination. So here is a prototype of a model where AI agent navigates by learning, finding mistakes, and resolving it to find the best possible route to reach the destination. The final result leads to the shortest route to the destination with the best visual environments. And here is a comparison between the two navigation model, human and the AI agent. I then calculated the urban fabric with respect to human movements. It is easy. The easier way to do it is to divide the city into smaller cells or grids. I then calculated the number of people stepping in a particular grid, how much time they are spending in a particular grid that we have chosen, and what is the dominant direction, which direction are they moving in that particular cell that we have. The overall comparison of the three data sets can be seen here. The major inferences being what usually seems obvious is never the obvious. Some of the secondary and tertiary road networks of the city, which are probably the very important routes, are actually one of the best routes to commute. And upon interacting within the city by movements, social media is also an essential parameter nowadays to quantify the spaces. For example, there are places in the city where you would prefer going and clicking pictures, be it Old Delhi or Old Dubai, be it any national monument, be it downtown Dubai or be it Times Square or Trafalgar Square in London. There are places you prefer going and clicking pictures. The reason we interact with these spaces and these spots is because these places have unique spatial and urban characteristics. Now, there are tools of designs where we can map the social impressions and it would tell us exact locations where the pictures were taken. And if we collect over 10,000 pictures and map their geolocations, the city would start revealing interesting characteristics, which I believe cannot be perceived by human brain. In the video, you may see the red nodes. These are the points from where the pictures were taken and uploaded on social media with the specific hashtags. It is even possible to monitor the emotion behind these pictures by reading and analyzing the keywords. The density of these nodes highlights the favorable areas in the city. Architecturally speaking, if you want to build a shopping mall, a tea stall, or any consumer-based model, now as a designer, we are capable enough to identify the right location for the better businesses and interaction within the city for the city inhabitants. So here is an overlook of the computational brain I created to understand the city fabric based on the parameters we just discussed. The aim of the brain is to identify within these parameters to establish a design language. The parameters that are being computed here are human movement, social media impressions, building volumes, and the colors from the social media images. Over here, the research highlights the particular area of the city which needs to be redesigned. In the initial process, the human movement is identified, followed by their visual preferences. The artificial brain then suggests the desired form tailored to that particular site. The research then celebrates the distributed and dynamic qualities of big data, which is utilized to generate the spatial layouts that are able to take advantage and respond to different local and global inputs, the environmental concerns, and the desires of the residents. Here is the cross section of the site with the built form suggested by an artificial brain. The form here has manipulated the buildings catering to the human needs and their preferences. Another visual highlighting the visionary space. It suggests that the form here is the right prototype with flawless human movements and it is socially well connected. So in order to test the artificial brain I created, it was important to test the algorithm on the other parts of the worlds as well. Up until now, all the data collection, the city fabrics, and the tests were specifically done for London. And to monitor the authenticity of the AI algorithm, I tested the same on Paris, more specifically on the island of Notre Dame. Well, after the Notre Dame fire, I thought it would be nice to pay some architectural tribute. The build form you see here is not to be confused with the final design output. Consider them as a general massing, and it is again in hands of designer to cultivate the aesthetics out of it. I was really fortunate enough that my research project was selected and presented as an exhibit at the Pompidou Center in Paris, along with some of the elite projects such as Morpheus by Zaha Hadid and Rafiq Anadol's Melting Memories. Moving forward, I would like to share a small simulation that I worked out for an architectural institute back in India, and I would like to call this as AI for FOA. The aim in this exercise is to establish and illustrate the spatial connectivity within this building. To the left, you may see some formal spaces such as committee room, waiting lobby, and principal office. And to your extreme right, you may identify some informal and student spaces such as thesis studios, staff facility, I mean, the lecture rooms, and etc. And upon running the simulation of spatial connectivity, you may see the corridor is acting as a spine of the building. The areas marked red and orange are the spaces with maximum spatial and visual connections, and the areas color coded with blue and dark blue are usually in isolation. That is, these areas are not very well connected. You may also notice the pocket of deep red nodes. These are the intersection zones with higher spatial connectivity as they are either intersected by a door opening or another perpendicular corridor. Another interesting inference is you might notice a difference between these two zones, the lecture room and the computer lab. Clearly, AI model suggests that the computer lab falls under blue zone and is not spatially well connected, even though the rooms are of almost similar dimensions. Analyzing the plan now, you may identify the difference being the door opening. What if we propose an opening on the other side of the lab as well? Would it affect the spatial and visual connectivity? So let's try that. And upon running the simulation, or let's say the AI simulation again with additional doors this time, the new spatial connectivity is something like this, what you see over here. And the both rooms are given equal importance. They are spatially more connected, and you would end up interacting with both the spaces equally. So let's add another dimension to it. Let's assume that you have to go from thesis studio to principal office. Point A being the starting point and point B being the destination. The AI simulation here is calculating the characteristics of your vision. What are the areas you would see while going from point A to point B? Let's assume that you detour a bit to catch up with your friend and then you head back. What you see here is the change while you move from point A to point B, and you can also change in the visible areas on your top right. This analysis would be interesting to determine the openings and the wayfinding. Having said that, most of the simulations and the ideas that I have presented up till now were developed on the Grasshopper, and I would give you guys a brief introduction about what Grasshopper is and how you can work on the Grasshopper. So if your Grasshopper is basically a plugin or a software for that is compatible with Rhinoceros. In the older versions of Rhinoceros, that is Rhino 5 or Rhino 4, you would have to download Grasshopper separately, which was a third-party app, and then you can run it parallelly with Rhinoceros. But with the newer versions of Rhino, 6 and 7, it comes already installed. So the way you launch Grasshopper is you will automatically load to your Rhino screen. Once it opens, the Grasshopper window basically hovers on your Rhino viewport, right? So you can see, I would request you guys to please turn your mics off. You might be creating or causing some disturbances to other participants. Yeah. Okay, so that's the Grasshopper window that you see, which is marked as one, and the area which is marked as two is basically the version of the Grasshopper that you're using. I'll dive in briefly into the interface of Grasshopper. Also, I would, while I'm doing that, it'd be great if you can just let me know through chat box if you have used Grasshopper. If yes, what is your experience level with Grasshopper? Are you a beginner? Are you an intermediate level? Or or you've, you, or if you have been using Grasshopper for quite a while, and you consider yourself as an advanced level, please do let us know. Our team would love to reach you guys with the right toolkits for you guys to benefit from this entire webinar, right? So make sure you do that. And this is how the entire interface of Grasshopper would look like. You would have the title bar, menu bar, and the file browsing controllers. Everything is marked over here. I'll share these particular introductory slides with you guys for you guys to understand and get used to the interface of Grasshopper. If you are willing to learn about AI, this is probably the right way you can start with it. And then the whole magic and the whole process happens in the canvas, which is marked as point 6. Point 7 is where it shows you your latest files or your recent files. It is the using of Grasshopper is pretty easy and straightforward. It might look very complex if you are a beginner, but once you get used to working on Grasshopper, it's a very straightforward, easy process that you can really pick up very well. All you have to do is just type in the component that you want, or you can drag and drop as well from the panels. If you just type in, the tool, or let's say the application, automatically suggests you few components. Let's say you're typing in divide, it will give you 4 to 5 options of different division things that you want, right from 1, 2, and 3, that you can see if you want to divide a surface or if you want to divide a number. It can be anything. So it helps you in your helps you guys to probably construct your own algorithm in much better way. Talking about the basic structure of components, any component is typically divided into 5 categories. That is the input tab, input options, body is where actually the magic happens. That particular part of the component holds the computational process, the computational power, and then after the computation is done, it gives you the output through output options and output tab. The Grasshopper, or the way you work on Grasshopper is basically a visual coding language. So let's say if you want to learn more about artificial intelligence, or you want to incorporate the idea of AI and machine learning, it all starts with coding. As an architect, as a designer, someone who doesn't have a computational background, it is seldom very tough to understand what coding is, and to probably learn a different language is definitely very tricky. This is where the Grasshopper is very handy. It is a visual coding language, so you are actually writing a code here, but then you are writing an algorithm over here, but then you are using all the components which you can visually see and identify. So all the C Sharp and C++ coding that are happening, it happens in the back of the components, and all you see are those cute little components, be it white or red or green ones, and all the process is happening behind it. And this is how the Grasshopper is actually helping us in creating much interesting and intricate algorithms in order to complex computational process as well. Connecting objects in Grasshopper is pretty easy as well. You just hover your mouse, you click the white bump to the other white bump, and it automatically connects. So constructing an algorithm is pretty straightforward. I would demonstrate a very small example to you guys as well. Before that, here is an object status where a single component can go into, let's say, 8 different objects statuses as well, right? This is something that you can go through it in your own time. I will share these slides with you all so that you can understand the introduction of the Grasshopper and how exactly it works. Again, it'll be very helpful for us as a team if we can understand how much or how aware are you of Grasshopper. If you're at a beginner level, if you're at an intermediate or an advanced level, do let us know so that we can share all the resources with you guys, keeping that in mind. It will definitely help you all. So make sure you put down your mail addresses and your names on the chat box and on the comment as well. So having said that, I've given you guys an example of the visual analysis. So I will quickly demonstrate a small script and how exactly you can do that. So this is how the Grasshopper interface would look like, and this is Rhino. So let's say this is over here, the red one that you highlight, that is highlighted over here, is where you can see all the buildings. That is where we want to create or conduct our visual analysis. And the curve that you see over here is the road upon which we want to construct and analyze the visibility. Okay, so the idea is pretty simple and straightforward. These are the input geometries that we put down, and the working and the functioning of Grasshopper is pretty straightforward. All you have to do is to, let's say, I want to start by illustrating the display properties of these geometries. So I can quickly hold the mouse and can connect the nodes. I move on to the setting geometries where I plug in the curve to the curve module where I'm evaluating the movement. That is by using the slider and I input the parameter. So what it does is, okay, it is not demonstrating because the points I haven't included the point. Yeah. So if you move from 0 to 1, it is going to move. It is going to travel from starting point to the end point. And we would like to construct or let's say develop a view rows algorithm for this particular space. And this is where the or let's say the computational process happen by using the component of view rows. So we plug in all the geometries because this is where we actually want to understand the these are our blocking units, right? So we plug in the brep, which is basically the context and the geometries to the context panel. And the plane is where from the point we would calculate the view rows. So I'll probably cover it in somewhere in the middle so that we have the better understanding of how the visibility might come out. And then plug into the view rows, and I will quickly plug in the view rows to the building edges. Okay. Oh, sorry, touching the wrong one. Okay, you're not able to see anything because the radius over here, I haven't given any input for the radius. I'll plug in the radius, which is basically my visibility angle. And once I do that, you can see from this particular point, these are the areas I'm able to see in the particular context. And this is basically a real-time simulation. So you can move from one point to another point and the areas will change automatically as well. And if I want to understand what are the other blocked areas, we can do that as well by plugging into the visualization part of it. You guys can go through this script at your own pace, at your own understanding. We will definitely share it with you all by end of it. Yeah, with this, I would now open up to question and answers, and I would love to know what you guys think about the role of artificial intelligence in architecture.
में ग्रासहॉपर आ सकते हैं।
So someone asked me about which software AI algorithm. Methodology that have been used. So the data collection over here is majorly through open source data portals that we have. The one for the London that I've used is gov.in for India, and if you want to gather all the resources or the data sets for India, you can do that as well. India has their own portal for it, and it's free, and anyone can use it. And all the visualizations that you have seen here are visualization on Houdini. I have done the visualization on Houdini. I have done the visualizations on Grasshopper animation as well. And there are
Can you teach us how to use Grasshopper another video lecture?
type it down so that mail address and your name if you're able to hear me. Is it all okay? Okay, so I think the connection is stable again, so I'll probably share my screen again. Just bear with me for a minute. Okay. Okay, thank you for that. So sorry, there was a technical glitch, and unfortunately, I lost the contact. So I hope you can see my screen and you're able to hear me. So again, please shoot down your questions. And as I was saying, we do have a WhatsApp community. We are quite an active community over here. Uh, Equim as an organization, we are in touch with more than 10,000 students and architectural professionals in the market. So, and we are trying to create something really interesting and very logical out of here in the field of architecture. So please join us. Join us on the group. Let's make this WhatsApp group, or the if you're sharing your mail IDs, our team will definitely reach back to you guys with all the resources. And most importantly, there were a few questions about the logical understanding of an AI and what are its uses. Well, the thing is, if you're designing computationally and if you are just focusing more on the forms, you might end up having a really good looking aesthetical building. But then, let's say in juries, or let's say in a practical process, you wouldn't be able to create a logical output out of it. I mean, yes, it looks cool or it looks fancy, but is it something that really is it sustainable? Is it viable? Is it something that you should really have it over there? And in practical aspects, and you usually as you go through your architectural journey as well in fourth year or final years when you're doing a thesis and stuff, you need to come up with something which is actually not very abstract. It needs to have a logical backing of it, which is why the computational approach of an AI is really important, which is why uh, the role of machine learning and artificial intelligence is something that we can bring into architecture in order to back up our design and our aesthetics to make a proper understanding out of it. And someone, Sanat, actually asked about is ViewRose a ladybug component? So ViewRose comes with a lot of components. There's a default component called ISOVist, which you can use to conduct ViewRose analysis. And yes, it is there. It is a part of Ladybug as well. Can we deal space syntax with AI? Yes, this question is by Daisy. So yes, Daisy, we can deal space syntax with AI as well. AI is an open source platform. Oh, sorry, space syntax is an open source platform. So just go to GitHub, you'll get the whole source code. You can copy the source code and then you can work it out the way that you want it, and you create your own AI platform. Okay, so Karan Preet is asking about some simulations on the screen, and he was wondering if the Grasshopper can produce animations. It can. Okay. Uh, Karan Preet, the Grasshopper can produce multiple animations as well. It does export. I mean, for obvious reasons, yes, you can get the still images, but then you can have all these images in certain frames as well, and you can compile them to create like a really smooth animation. So it is possible to do that on Grasshopper as well. Okay, so the other softwares that are related to Grasshopper, like Ladybug, etc., can I quickly brief on these, please? Okay, so first of all, these are not actually the softwares. These are the plugins that comes with the Grasshopper. You can download an n number of plugins using through open source website, or let's say a platform which is called as Food for Rhino. You can download any number of plugin, and every plugin has its own plus points. How do we train neural networks using Grasshopper? So this is by Sanat. So Sanat, it is possible to do, or let's say compute neural network in Grasshopper by using a component, or let's say using a plugin of Lunchbox. So the Lunchbox plugin comes with the machine learning components, and you can train all your data sets using that particular one. What kind of projects we can use AI? As per my understanding, design is guided by concepts. So this question is by Pankaj Motwani. So Pankaj, yes, on at a bigger picture, yes, any project is derived, or any architectural project is derived by a concept. But then the whole understanding of AI is to back up your concept. Your concept might be, let's say, XYZ. You want to create a high rise, which you might have a really strong concept about, right? But then, how many floors would you want for your high rise? What should be the orientation of your design, or let's say, as per your concept, you want the building to face north south or east west. This computational analogy would then help you in bringing up the understanding, and you can actually support and back up your concept. So just by designing aesthetically, let's say if you're able to score 5 out of 10, if you're backing up your design with aesthetics and the logic, you can easily score 10 on 10. So this is the question for a person who has never learned coding. What do you recommend us to explore or practice first before we start learning Grasshopper? Okay, so there is no right and wrong time to start Grasshopper. The sooner you start, the better it is. This is probably one of the first steps that you do in order to get into the AI world of architecture. So I would definitely encourage you to do that. From here onwards, it gets a bit trickier, right? So if you know about the coding languages such on Jupyter or Python, or let's say C++ or C sharp, you can straight away dive into that. But then if you don't have any coding language, I would recommend you to just start with Grasshopper. How would a freshly graduate architect pursue a career in AI and computation in the field of architecture? Well, it's the approach. I agree there are not many organizations that are working on it, or probably are very happy in incorporating AI into architecture. But since you have joined this webinar, I'm pretty sure that you guys know and feel that the AI is the next big thing. The AI in architecture is the next potential thing that we can have in next 5 to 10 years. So for a freshly graduate architect, I would just recommend you guys to look for start practicing it. Which is why I was saying that we as an organization, Equim, we do a lot of workshops. We do a lot of uh, boot camps. So if I have to quickly go through uh, our websites that we have, so we have conducted innumerous, I mean, numbers of workshops where we have trained more than 10,000 students, and they are already in the field and doing really good in different parts. Actually, these are not just from India. They're into there are few in US, there are few here in UAE. So we get positive responses from them. So if you guys are interested, if you feel that there is something that you can take forward as a boot camp or as a workshop, we have a workshop coming up in next couple of days, that is from 26th, 27th and 28th. Whatever I've shown you guys is already here, uh, split up in 3 days. You can go through it. We'll share the links with you where we will be doing we'll be getting into space syntax, we'll be getting into generative learning tools. And it's okay if you are a beginner. So it is going to be a steady process. The course is structured in a way that any, like if you're a beginner or if you're an intermediate level, it'll be easier for you to understand and you can grasp it. So here are some testimonials from the students that we had recently, and please make sure you go through these. And also, right now we are doing a flash sale for the workshop. And I would also like to show you some of the students' work that we have previously in the previous versions. We had some really interesting outputs from them. So if you guys think that yes, this is something that you can go through it, I would definitely encourage you all. Our team will surely reach out to you guys, and we will share all the necessary links. We'll share all the resources with you all, be it the script that I was showing you guys in order to create a view rows diagrams, or be it some of the initial slides of what is Grasshopper and what you can do about it. So yeah, if you have any more questions, I would love to take a few more, and then probably we can call it a day. Okay, someone is asking about the Dynamo. Is Dynamo similar to Grasshopper? Since it is also a visual programming tool, So which one to learn? Okay. So let's say if you are well exposed to Revit, I would encourage you to go and practice Dynamo since you already know Revit. Since most of the students or people they are more exposed to the SketchUp stuff, I think the Rhino and Grasshopper opens up. It is more for them. But again, in Dynamo, it has few limitations. Not all the plugins are actually working there. They're not compatible with Dynamo as of now. But then with Rhino and Grasshopper, um, it's everything. You can do anything and everything over there. You can write your own code, and then eventually you can create your own components out of it, which is not something which is possible in Dynamo. Okay, so there's a question by Niharika where she's asking about, do we need the final form from all the multiple solutions to a problem? Unfortunately, I couldn't understand the questions quite clearly. So Niharika, if you can rephrase your question again for me, it will be really helpful. But what I'm able to understand from this is, will Grasshopper help you to derive the final form? It is possible to do that, but it is done using generative learning tools. So again, as I said, it will give you numerous millions of design possibilities, and using the right tools, right generative algorithms, which is basically a machine learning algorithm, you can do that and it will give you one in the million form. So yes, the Grasshopper will give you that. Okay. So how is the computational architecture market working in India? So this is by question. This is the question by Kushal. So right now, not many, as I said, not many organizations are currently working with it, but then they are getting being exposed to it. They are accepting it quite well as well. Unfortunately, I won't be able to coin the names of the architectural firms at the moment, but yes, if you look into just the computational architecture in India, or there are people in Indian market who are working, who are accepting, let's say, artificial intelligence and architecture as well by using the big data and generative learning tools. And also, I would like to remind you guys again that we have the flash sale going at the moment, so which will end in a day's time. So if you guys are interested, and if you think this workshop or this logical thinking in architecture is something that you guys are interested in, I would definitely encourage you guys to enroll for it. If you are enrolling for any particular course, let's say you are enrolling for AI Urbanized, it is basically for your lifetime. So let's say you enroll for the course, you attend the workshop that we're going to have over this weekend, and if, let's say, in a month or two we organize another AI bootcamp, AI workshop, you can attend again. So it is possible to do that, and it's something for the lifetime. So we are trying over here to build an organization or build a really fruitful community. uh, Soon, we are also launching a combined workshop, which is the parameterized and AI urbanized. So parameterized is something for the beginner levels who have no knowledge about Grasshopper, and AI urbanized is for someone who knows what Grasshopper is and is at intermediate stage. So we are launching soon a parameterized and AI urbanized combined workshop module as well, wherein which is not in the website as of now, but by tomorrow it will be there for sure. So I would again encourage you guys to go through it and look into it. Um, the workshop, the flash sale. Okay. So as I was talking about all the analysis and simulation that I've shown you guys, what all you can do, we will be doing that in the workshop as well. So if this is something that you guys are really interested in, please do download the brief. I have even listed down the names of the components or the plugins that we are going to use, about my background, and most importantly, uh, the flash sale that we have is just there for one more day. Okay, I think I've had another question. Okay, so I don't get how we feed the data to Grasshopper. For example, I spoke about aesthetics of the building and said if we can back up aesthetics with solutions to design problem, then it's better for our design. So how is Grasshopper figuring out the problems? Do we need to feed in the data like population, etc.? Okay, to answer that in a very straightforward manner, I would say yes, it is possible to feed all the data to the Grasshopper. You can do that by um, the Excel sheets. You can get all these open source data from the government websites. It is possible. You can just input that to the Grasshopper, and since these Excel sheets are with 10,000, 20,000 cells, it is kind of impossible for a human brain to process. So this is where the Grasshopper is actually helping us. And again, if you are not able to find any data, it is possible to collate or let's say construct your own data set as well. So let's say I gave you guys an example of the social media analysis. So I took the data from let's say the social media platforms in order to understand what are the hotspots in the city, and you can construct your own data to bring up your own inferences as well. So a lot really depends on the way you construct the algorithm. So again, guys, we have the WhatsApp group as well. So make sure you put down your name, you put down your mail ID, so that our team can share all these resources with you guys. uh, So again, for this workshop, which we are going to have by the end of this week, we just have 6 more seats available. Uh, Better rush, better now than never. So please do have a look at the workshop modules. You can download the briefs as well, and I would love to see you guys back then. Okay, so guys, I think I had a great time with you all. I hope the same for you guys as well. We will share all the resources that I've talked about a couple of times during the webinar and now again. So we will share that with you soon as possible. Thanks for attending the webinar, and cheers and have a good day. Stay safe.